Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. In this episode, I am picking back up on my game engine, and this is going to be episode 7, the 7th episode, episode number 6. I did start with 0 counting, and that is slightly hard for humans to deal with. So I have gone over the plan. I do suggest that you go back and you watch these episodes. And I've gotten to reading the SFML joystick states and displaying the states. So we cleaned up the code a little bit in the last episode. And as you can see here, I can handle and display all of the states real time live. We can also see that I don't quite center out here, but that's okay. Actually, that's kind of a high number there. I don't know if I blame the joystick or if I blame the way that I am reading the software. So, well, we're dealing with game events is what we're dealing with in this episode. So let's take a quick look at that actually. Now, my code here for getting the, let's see, I put this input helper. I have this load joystick here, and this goes through, it gets the identification, and it refreshes all of the joystick state stuff. So let's make a separate function. We'll take this by reference, I guess, for this one. Oh, these should all be static functions. I'm going to get a linker error in the future if I don't handle these static or inline. Now I have an interesting question to deal with here. First of all, I do know the ID of this joystick. There is this SFML feature called, let's see, joystick update. So it updates at that moment the current state of the joystick and reads it in. I don't know if I want to call that right now or not, honestly, but I've got this refresh joystick function. And I'm going to leave this update in here for the moment, and we're going to see like what kinds of things happen. So down here, I am writing my joystick state output. So let's check this out. If I do, what did I call it? I did call it refresh joystick. Okay. Oh, that's right, it's in a namespace. So now I'm explicitly loading the joystick state before I do anything to act on it. I'm not relying on the last processed state from SFML. And I'm going to do the same exact thing that I was just doing and bounce these joysticks around. Guess I'm going to blame my hardware for this one. It looks like that SFML's event processing is pretty solid. So I don't need to manually refresh this joystick state. I am not at the moment putting any of these functions inside the joystick struct, because what we want to do is aim towards something that can be replayed. What we want to do is work on the testability of the game. Now, if you go back to my to-do list, managing game state and making our game testable are supposed to come quite a bit later. But I'm going to look at this right now. So I am building up these joystick events. And I need to know what to do with the set of joystick events because I want to replay this. And again, we have this question of, do I say there was a joystick event and this is the new state? And therefore you replay whatever the current state is. That's probably the most portable way to deal with this. So I don't have to say a specific event occurred at a specific time. I can say at this particular game tick or whatever. I just got that game tick from the work on the Doom game engine that I've been doing with my C to C++ refactoring of that code. And then I came to this because I needed to deal with keyboards. So this is all the SFML update of its stuff, but we need some way to replay this somehow. So I need some way to convert like an SFML game event or event into one of my events, and then I need a way to pass that event back into the SFML MGUI handling of these events so that, let's see, where is that code? That is this MGUI SFML process event. And I need some way to be able to drive this because I need to be able to make this game engine testable. So I am leaning towards this ability to get the next event with the current state of the joystick, and that may prove to be a problem because I will probably be doing lots of copying around of joystick objects. And how did I make my joystick object? It's not tiny by any means. It's got this string in here for its name. Maybe we just don't need that right now. It's got 2 ints, 2 arrays, an array of bool and an array of floats. I don't want to exactly mirror the stuff from the SFML processor. So let's go ahead and try to make some sort of input handler or some sort of event processor. That wasn't working properly in the last code anyhow. All right, so I'm building towards a game engine that is going to give us a reproducible state and a managed state so that at any given moment we know the state of the engine. It is something that we'd be able to serialize, something that we'll be able to reproduce, and something that we'll be able to play back. That is the main goal here, is I'm trying to do a playback of events here. Hopefully this will start to work. We've got the delta clock, we know how much time has occurred, and we'll know what the joystick pad game state was on each event. So I'm going to create a game object. It's the current game state. I'm going to process this event. This is going to give me back some sort of an event object here. So now I've got a set of joystick events that I can work with. Why didn't that compile? No, I don't want to split into declaration. Process event is never used. It's in the object game state. It's telling me game state is never used. Game state is definitely used. It's right there. So let's compile this. Declaration of event. Oh, I see. Okay, that's, yeah, all right. So process that event. Now, this is pretty good, I think. I'm probably going completely down the wrong road because I don't really know what I'm doing here. But we're, again, continuing to make the game engine at least slightly more maintainable at each given juncture. And so I am outputting the current, actually, this is going to be interesting. Let's do this. And then we'll wrap this episode up and we'll wonder, I think this is starting to, I hope this is starting to make sense. Now I'm going to use a vector right here, and I know someone will complain about this, that you would never use this right here, but that's okay, we're going to anyhow. And this is going to be one of my events. This is my abstraction, this is my replayability. And that is going to be the set of events here. Now, trust me, we will deal with a lot of this potential inefficiencies and that kind of issue in a moment, in a few episodes. Okay, so I've just handled all of the events from the system. I've let SFML process those that it wants to. And now I am going to do my own processing of these events. I'm eventually going to have to abstract it out so SFML also gets the events that it wants to. But I'm going to have the delta clock time change and the event being processed at the moment. Now see, I know I don't want to redraw the entire UI for each game event. I just want to process them and do whatever game thing needs to happen for those events. That is more in line with what I actually need to do here. We're going to go ahead and borrow our variant overload implementation. That is the kind of thing that we've been doing since all of these episodes that I've done over the years on why inherit from lambdas and that kind of thing. And we never really felt like we had a clear answer. Now is a place for a good, clear answer. All right, so this joystick event should be being reset to false on each game loop this time, and we're doing this overloaded visitor thing. Again, the goal is to lead towards testability and to be able to replay game events. That's the goal. We want to be able to save the game state. We want to be able to replay events. This is all getting a little long-winded. Let's see how this looks. Okay, so we see whether or not a joystick event was processed during that thing. Now, one question that we're still going to have is how many seconds or whatever elapsed between each of these events. And at the moment, we don't have any way of dealing with that. But the game close method did work, and we've got our visitor. So this is going to end up becoming like, this is what we need to be able to do here. So each of these game events, now we're going to actually start like doing things or have the ability to do things. And so where are we? This is dealing with game events. Yeah, okay. So let's just say that this episode is done. We are starting to get to the state where we're being able to deal with game events. I don't know why this is. All parameters should be named in a function. Oh, clean tidy analysis coming back at me. No, I don't want to name those parameters at the moment, but I am going to have to deal with you shortly, clean tidy. Okay. So yeah, we're getting to the point where this is starting to get a little bit more abstracted, a little bit more reusable, a little bit more savable and replayable. So we would be able to, at any given moment, have what the current game state was and what events were played out for that game state. Now, the next thing that we need to keep track of is how much time elapsed between that game state and those events being processed. And so we actually are already keeping track of that, right? This is right here, this SFML update delta clock restart. Let's move this up here. And what is this delta clock restart? It's an SF clock utility that deals with elapsed time. Restart returns a time. Okay, what is a time? Time is the number of seconds, microseconds, milliseconds that have elapsed. All right, so let's see. Milliseconds would be in the thousands. If we had 1 millisecond elapse, then we've done 1,000 frames per second, or 1,000 game events or whatever per second. So that's, you know, I know in the Doom engine that this is abstracted out into game ticks versus time ticks. So if we just say that this is equivalent to however many milliseconds occurring, so let's go with millisecond resolution. And then our game state. Now we can do this, and I'm going to do this for the fun of it right now. Vector. Do I really want to use a vector? I don't really want to use a vector because a vector is going to grow big quickly. Let's just do this. Actually, no, let's do this. I know what I'm going to do. No, I don't know what I'm going to do. All right, we're just gonna kind of keep track of this at the moment. this input object is becoming, this input file is becoming increasingly misnamed. It's now the entire game state, and it has SFML logic baked right into it, and the whole point of moving it out here was to abstract that away. So we're going to have to do something different with that in an upcoming episode. Let's just go ahead though and give us some sort of okay, yeah, I'm going to stop here. So we are keeping track of how many milliseconds elapsed, I think. No overload of variable. Oh, right, that's a chrono object. Okay, there we go. So not implicitly convertible, but now we've got some strongly typed thing. We know the number of milliseconds that have elapsed, and we know all of the game events that have occurred in that number of milliseconds. So we're starting to get to something that can be replayable. So yeah, thanks for watching this episode of C++ Weekly. I will come back to keyboard input in the next episode. I'm going to cut this off here. Hopefully this has been entertaining or useful or interesting in some way. These are the kinds of things that I'm dealing with when I am trying to use different libraries from different eras of C++, and some things that I think will probably end up leading to a very clean engine. Hopefully it won't be too slow in the decisions that I'm making and my naivety. So thanks again.